This is question 12 from section 10.3, and this is a great question. I always love going over this one. The character in the problem is delivering pizza, I think, to people probably during the coronavirus scare, and gets pulled over going 50 miles per hour. And the speed limit's 30, and they charge $7 per mile per hour over 30. So 7 times 20 miles per hour over the speed limit ends up being a ticket fine of $140. The person says, no, you watched me for a 4-minute time period, and in that 4-minute time period, I started out at 30, and yes, I was speeding, but I was only at 50 miles per hour for a split second. For that 4-minute time period you were watching me, my average speed was much, much less. Okay, so this is a velocity function. That's what we've got over here. And remember, the whole idea of average value of a function is you want to find the average. I can't add up the infinitely many different points on this function, okay? But the average value of a function will allow me to figure out what the average value was, and that incorporates even, if you stay some values longer than others or that kind of thing. It all comes out in the wash. So anyway, it's a pretty straightforward formula. However, you need the equation of the curve, okay? So a little bit of, I don't know if you want to call this algebra 1 or if you want to call this algebra 2, but anyway, we need to write the equation of a parabola, and it's a great setup. You know from probably higher end of algebra 2 and pre-cal that sometimes if you just have 3 points, you've got to write something in the form ax squared plus bx plus c, and you've got to write a 3-variable system with 3 different points that it passes through in some cases to write the equation of the quadratic. You don't have to do that here because you have a vertex. Heck, you've even got a y-intercept. So you should just be able to use vertex form here, transformations. So if you've got something like y equals x squared, if you had something like y equals x minus 3 squared plus 7, the vertex would be moved 3 to the right and it would be moved up 7. So most of you probably learned some kind of variation on this. And by the way, you can have a multiplier out front that would stretch it in different ways. So I'm not exactly sure the exact formula you learned, but you've got your horizontal shift here in parentheses, squared. You've got your multiplier out front, and you've got a constant there added at the end, okay? I use h and k, which are probably the values used for horizontal and vertical shifts for example, circles, ellipses, those kinds of equations. Anyway, long story short, the vertex is going to be at 250. So you're going to need an x minus 2 for your horizontal shift. It's going to be shifted up 50, so your k value is going to be 50. And we do need to know what this multiplier is out in front. We know it's going to be negative, but that doesn't mean that it wasn't stretched, or widened or something like that. So we still have to find that a multiplier out in front. But the great thing here is we can just pop a point here and test it. And it doesn't really matter what point. I think that point 0, 30 might be really easy to put in here. But just sub a point in and check and see what a has to be to make it go from that vertex through that point. So we want y to be 30 when x is equal to 0. And anyway, if we work this out, that's 30 equals, negative 2 squared is 4, so that's 4a plus 50. Subtract 50 on both sides, negative 20 is equal to 4a. So a there is going to be negative 5. So our function is y equals negative 5 x squared, x minus 2 squared plus 50. Okay? And at this point, we can just stick this in the average value formula and be done with it. So let's go ahead and do that. Remember, the average value of a function is the integral of the function over the range that you're looking at. So it's negative 5 quantity x minus 2 squared plus 50, dx here. And remember, you divide by the length of the interval, which in this length case is 4. I don't think there's particularly any reason to try to do this by hand. Certainly you could FOIL that out and you could do it by hand, but they don't ask us to show that here. So I'm going to go to my calculator, math 9, integral from 0 to 4, and do negative 5 quantity x minus 2 squared. Don't forget the plus 50 there. I think that will make a difference. And so we've got that integral, and then we're dividing by 4. So it's 173 and a third divided by 4. And let's see, if we do that, we're going to get 43 and a third, okay? Remember, average value, it's the average value of the function you're dealing with. Your units don't change. Actually, originally I was thinking the fact that the interval was in minutes, hence something to, might affect things, but that comes out in the wash if you remember how we set this up originally. So the interval units don't matter. So it's going to be 143 1/3 miles per hour is the average velocity, or in this case it's positive, so average speed. Okay. So anyway, it's $7 per mile per hour over the speed limit of 30. So whether or not you're taking 13 1/3 and you're multiplying by 7, I'm guessing they would probably count this as being 14 miles per hour over the speed limit. 14 times 7, not what I know off the top of my head, is $98. I'm guessing that's probably how they would do it. Let's go back and look at the original wording here and see if they say anything. Let's see. Yeah, it just says $7 for each mile per hour over the 30 mile per hour speed limit. So I'm going to assume that they would count that 1/3 of a mile as an additional mile per hour. If you took 13 1/3 multiplied by 7 and got something slightly different, I think that would also be okay. But neat problem, neat application, and little view there of writing equations of quadratics.